Hello and welcome to my channel. In this video, we are required to find an expression for cos theta provided that sin theta is equal to m squared minus n squared over m squared plus n squared, and theta is acute and m is greater than n. Before I proceed, I would like you to do me a favor. Please like this video if you find it interesting, subscribe to my channel if you haven't done so, and also share this video. Sharing is an act of love, and love doesn't cost a thing. I am going to use two methods to solve this problem. The first one is by applying the Pythagorean's theorem. Let us assume that here is theta and this is a right angle triangle. Now, here is the opposite side and here is the hypotenuse side, while here is the adjacent. If here is the opposite side, then here is m squared minus n squared as we have it in the formula. And if here is the hypotenuse side, this is m squared plus n squared, and this side becomes the unknown. So if we now apply Pythagorean's theorem, we have it that hypotenuse squared is equal to the adjacent squared plus the opposite squared. Now, the hypotenuse squared is m squared plus n squared. Let's square it. The adjacent is this side, that is x squared, and the opposite is this side, m squared minus n squared. We now square it. Now, let's find an expression for x. So, x squared will now be m squared plus n squared minus, here is m squared minus n squared. Let's square them. We now have an expression for difference of two squares. Let's remember that in difference of two squares, a squared minus b squared will be given as a plus b, then a minus b. Let a be m squared plus n squared and b be m squared minus n squared. So our x squared will now be given as difference of two squared, that is m squared plus n squared plus m squared minus n squared in a bracket. In another bracket, we have m squared plus n squared minus m squared minus n squared. Let's close the bracket. Now, if we open the bracket, x squared will now be m squared plus n squared plus m squared minus n squared, where this and this will cancel out. And if we open this bracket, m squared plus n squared minus m squared plus n squared, and this will cancel out. So we are now left with 2m squared times 2n squared. Now, that can be written as 4m squared n squared. So if we find the square root of this, we have 2m times n. So this is the value of x, which is the adjacent side. Now, we define cos theta as the adjacent side all over the hypotenuse side. The adjacent side we just found is 2mn, and the hypotenuse side is given as m squared plus n squared, m squared plus n squared. Therefore, cot theta is defined as cos theta over sine theta. So our cos theta is 2mn over m squared plus n squared divided by sine theta is given as m squared minus n squared over m squared plus n squared. So we put it there, m squared minus n squared over m squared plus n squared. Now if we divide this and this will cancel out, remaining 2mn over m squared minus n squared, which is our cot theta. So this is the first method. Now let's use the second method. The second method is applying this trig identity, sine square theta plus cos square theta is equal to 1. We know that sine square theta is given as m squared minus n squared all over m squared plus n squared. Now we'll square it. Plus cos theta or cos squared theta equals to 1. So cos squared theta will now be 1 minus m squared minus n squared squared over, and I have m squared plus n squared squared. What I did here was that I applied this property of indices. A over b all raised to power m, for example, is a to power m over b to power m. So this property is applied here, whereby I distribute the power over the numerator and denominator. So if I simplify cos squared theta, I will have m squared plus n squared as the LCM, and here is m squared minus n squared all squared minus, and I'll have m squared plus n squared squared. So if I apply difference of 2 squared here, cos squared theta will now be 4mn squared here over m squared plus n squared raised to power 2. So squaring both sides, cos theta is 2mn over m squared plus n squared, just as we have it here. Now, the cos theta is defined as cos theta over sine theta. And when we substitute, we have 2mn over m squared minus n squared.